Hello students, welcome to Educate. In the last class, we have discussed till question number 1.4 of the exercise. Chapter 1, that is more concepts. Now we discuss the question number 1.5. What is question here is, you will have to find out the mass and their volume of the solution is 500 ml. This one concentration of the solution is 0.375 molar and the molar mass of sodium acetate has been given. So already, the molar mass of sodium acetate has been given, so you will not have to calculate that. So here very simple question it is here. So what is here? Molarity is 0.375 means in 1 liter, the number of moles of sodium acetate will be 0.375, and it is asking here volume of the solution is 500 milliliter. 500 milliliter means half liter. So half liter there. So number of moles will be also half. Okay. Molar mass is here. So number of moles, what you will find out here, that when multiplied by the molar mass, that will be the mass of sodium acetate dissolved in 500 milliliter of the solution. Okay. So let's see here. How is that? So 0.375 moles of sodium acetate is present in 1 liter. That is 1000 milliliter. So number of moles of sodium acetate present in the solution is 0.1875. Now its mass will be, that's number of moles into their molar mass. So mass of sodium acetate will be this one into their molar mass. That means that one. Calculate that. That will be the answer. Multiply that. Okay guys, very simple question it was. Now let's proceed the next question. Guys, which questions are easy about that also I am discussing. Yes, I shall not discuss about those questions which will be of same type. Now let's see here. What the question here is? Firstly, watch out. Here it is mass given here, density of the solution is given of nitric acid. The density has been given and its mass percentage has been given also. And you will have to find out its concentration in moles per liter. That means here in this question, the density of the solution has been given, the mass percentage has been given, and its molarity has been found. That is concentration in terms of moles per liter it is. So you will have to calculate the concentration of nitric acid in moles per liter or in terms of molarity. Here, how much? 69. So guys, 69% of nitric acid is here. Guys, here the mass percentage of nitric acid is 69%. Means if the total volume of solution, if the total mass of solution, if the total mass of solution will be 100 gram, then the mass of nitric acid will be 69 gram and remaining will be water. Mass percentage of nitric acid is 69%. Means if the total mass of the solution will be 100 gram, then mass of this nitric acid will be 69 gram. Okay. Total mass of the solution is 100 gram and density of the solution has been provided. That is in gram per milliliter. In gram per milliliter. So density of the solution has been provided and you can find and you have assumed the mass of solution as 100 gram. So total volume of the solution will be how much? So you know the formula, density equal to mass upon volume. Mass you have assumed, so volume you can calculate, and the volume which you will calculate, that will be in terms of milliliter. Milliliter, convert them into liter, and then after find out 69 gram is there nitric acid. There is 69 gram nitric acid. So number of moles of nitric acid find out. So number of moles of nitric acid you will have, and you will have the volume of the solution. So you can find out molarity, that is number of moles of nitric acid upon volume of solution. Very simple. Let's see here also. I am don't worry. I will solve this question. So let's see here. HNO3, nitric acid is HNO3. Okay, this one is here. Now let's see here the density of the solution. Density of solution, that will be equal to mass of solution upon volume of solution. Density of solution has been provided 1.41 gram per milliliter. So that means why milliliter here? Because gram will cancel out. milliliter will go in the numerator, that becomes milliliter inverse will go in the numerator, that will become milliliter, that is volume of solution. Now to calculate molarity, you have to find out number of moles of nitric acid, that upon volume of solution. So volume of solution here in milliliter, either you convert directly here or here. That means here it is milliliter, so convert it to liter. That means 0.07092. That much liter here. So first of all, you will have to calculate number of moles of nitric acid. So firstly, nitric acid molecular formula will be what? Nitric acid molecular weight will be 63. 1 hydrogen, 1 hydrogen, 1 nitrogen, 14 hydrogen here, 1 nitrogen, 14. There is 3 oxygen and atomic weight of oxygen is 16. So how much? 16 through 3 is 48. So 1 plus 14 plus 48. When you add 8, 4, 12, 1, 13, carry 1, 4, 1, 5, 1, 6. So 63. So here at molecular weight of nitric acid will be 63. So number of moles of nitric acid will be how much? There is how much number of moles of nitric acid? Okay. So 63 and weight of nitric acid 69. So 69 by 63. So number of moles of nitric acid will be 69 by 63. 69 gram upon 63 gram per mole. So yes, gram will cancel out, mole inverse will go in the numerator, that become mole. So that will be 69 by 63 mole. That is, so now molarity here 69 by 63, that upon this one 0.07092. So molarity it is in mole, it is in liter. So now 69 by 63, how much is coming? Guys, watch out, main division line is about here. This one is the main division line, this one. So that will be 69 by 63 into here above 1, so 1 upon 0.07092. That much moles per liter. That comes 15.44. So molarity of the solution will be 15.44. Okay. Okay guys, where is it is? No, that's watch out firstly. Who would like to copy? May copy. Then after let's see about this. Now let's see. Question number 1.7. Let's see. What is there? How much copper can be obtained by 100 gram of CuSO4? So let's see here. Copper atomic weight here CuSO4 100 grams. Copper weight of copper this CuSO4 is 100 gram. So let's see here CuSO4 firstly molecular formula. CuSO4 what will be? Copper 63, sulfur 32, oxygen 16 into 4. How much? That is 63 plus 32 plus 64. Copper that is here 63 point something, so you may take 64 also. 63.5, so 60, you may take this one also. Okay, or leave this one. So there is how much? 100 grams CuSO4 solution. So when the total mass of the solution, when the total mass of CuSO4 will be 159, then copper will be 63. So that means 159 gram of CuSO4 contain 63 gram copper. So 1 gram will contain how much? And there is how much? 100 gram copper CuSO4 you will have to find out. So in 100 gram that will be okay guys, so that will be here, that will be 63 divided by, so do that, calculate this one, 6300 divided by 159, that is 39.62, that will be 39.62. Okay. This one now let's see next question 1.8. What's the question read? Let's see here, firstly read that question. Question is 1.7 and 1.8. Determine the molecular formula of oxide of iron in which the mass of iron and oxygen are this one and this one respectively. So mass of iron is given and mass of oxygen is given here. So mass of iron and mass of oxygen here, that given here. So you know already to calculate the molecular formula, to calculate the molecular formula, you will have to find out the number of moles of iron and the number of moles of oxygen, and in which ratio they are present, that will be the empirical formula. And then after here, we will find out the molecular formula. It's the ionic compound. So usually the empirical formula is equal to molecular formula. Okay. So what's here? Amount of iron has been provided. The amount of iron has been provided. The amount of oxygen has been provided. The amount of oxygen has been provided, and that's you will have to find out the molecular formula of the compound. So how to calculate? So number of moles of this one iron you will have to find out. So that will be 69 by 56. So that will be here. So number of moles of iron will be 69 by 56. That will be number. In the same way, number of oxygen you will have to find out. That will be how much? That is 30.1 and 30.1, and oxygen molecular weight is 16, atomic molar mass is 16. So that will be number of moles will be that much. So let's calculate 69 by 56. That is 1.23, and that of 30.1 divided by 60, 30.1 divided by 16, that came 1.88. So 1.88. This one. Now ratio of, so to calculate, you will have to find out ratio of number of iron is to number of oxygen. That will be 1.23 is to 1.88. So you will have to here 1.23 is 1.23 just molar. So you will have to divide 1.88 by 1.23. You will have to divide 1.88 by 1.23. That gives 1.5. So that will be equal to 1 is to 1.5. Here this ratio you will have to make in terms of whole number. So what to do? 1.15. So multiply both sides 2. So 2 is to 3, that will be. So formula of the compound will be iron will be 2 and oxygen will be 3. So formula or molecular formula, whatever be that, molecular formula. So molecular formula of the compound will be molecular formula of the oxide of iron will be Fe2O3. Okay guys, here we have discussed. Now we will discuss from here in the next class. Okay, in the next class we will discuss from here. So it's all for this class here, because it is related to the atomic weight. You first of all practice these questions, then after we discuss about this.